Hey guys, welcome to another episode of Stop Loss Investor. My name is Sai, and today we're looking at Nvidia and their vision of AI. And before we get into the presentation and just see what Nvidia has in store for the world of AI, I just want to talk about their recent, I guess, Jensen's comments on ARM and their acquisition of that company. So this is something Jensen said in a recent interview on the 21st of November, where he said, "There's nothing on my radar. All the businesses we're in are super competitive. Arm has giant customers, the new markets they want to grow into. They're the severe underdog. There's every reason to believe that by adding more horsepower to Arm, we're going to increase customer choice and increase innovation in the marketplace. Our assessment is that regulatory is going to be quite favorable to this transaction." And so, with that being said, I think we can take into account that this deal might get done. I think um, Jensen and the CEO of both have said that this deal might take anywhere from a year and a half to 2 years to get done. So we probably won't see it be merged into the business of Nvidia till then. Until then, the partnerships will continue. They are obviously very much working in tandem with ARM on various different things in parallel processing and accelerated computing. And I think this acquisition is more to just make it under the one umbrella of Nvidia. Um, but yeah, we'll see how this hat goes. I'm much in agreement with Jensen. I think this will be quite favorable. They're kind of two different uh, areas. They don't really work. They work parallel to each other. They don't work. They're not really anti-competitive. So we'll see how that goes. But with that being said, we'll get on with the presentation. So in this video, I'm just gonna talk about Nvidia's, like in this video that we're gonna watch here from Jensen's GTC. It's just gonna be about their developments in AI and how computing is going forward. Now I'll just move to the part where he starts talking about it. Okay.
That's a great GTC. This is an amazing time for the computer industry and the world. As mobile cloud matures, the age of AI is beginning. Why is AI so important? Why is it the most powerful technology force of our time? Computing is the technology of automation. Software algorithms automate. Automation drives productivity and growth for industries. For example, farming automated food production and revolutionized society. Automation lowers costs for consumers and make life more convenient. Automatic electricity and water improve our quality of life. Automation at large scales lead to breakthroughs, just as search has automated getting information and getting answers. There are many things we like to automate. We're limited by our ability to write the software. Finally, after decades of research, deep learning, the abundance of data, the powerful computation of GPUs came together in a big bang of modern AI. Now software can write software. So AI is the automation of automation. Incredible implications. Let's explore some of it today. The software written by AI is very different than that written by a human. It is vastly more parallel and thousands to millions of times more compute intensive. The method of developing the software is different. The computing infrastructure is different. The tools are different. The software runs differently, and even the method of deployment is different. AI requires a whole reinvention of computing, full stack rethinking, from chips to systems, algorithms, tools, the ecosystem. Nvidia is a full stack computing company. We love working on extremely hard computing problems that have great impact on the world. This is right in our wheelhouse. We're all in to advance and democratize this new form of computing for the age of AI. Nvidia is dedicated to advancing accelerated computing. Enabling developer success on our platform is core to everything we do. GTC is all about developers. Developers adopt a new platform only if it solves a problem 10 times better, and that has a large and growing installed base. And developers need great tools. Domain after domain, graphics, high performance computing, data science and analytics, artificial intelligence, healthcare, self-driving cars, robotics, to the 5G edge. Nvidia created platform SDKs to make it easier for developers to tap into the power of Nvidia computing and make it easy to deploy your software on Nvidia computers in every cloud and any data center and edge. This GTC, we're releasing 80 new and updated SDKs. There are now a total of 110 SDKs. Developers need an architecturally compatible and significant installed base. Nvidia has shipped over 1 billion CUDA compatible GPUs. CUDA SDK has been downloaded 20 million times and 6 million times this year alone. It is clearly accelerating. 1,800 applications are now CUDA accelerated. There are 6,500 startups building on Nvidia. The top developer SDKs include Nvidia AI, Nvidia RTX, Nvidia Rapids for data science, and Nvidia Isaac and Drive for robotics and autonomous machines. There are over 2 million Nvidia developers now. 600,000 joined this last year. To all, a big welcome.
That was a fantastic beginning there from Jensen. So to just see how the growth's impacting and how it's going forward and what they're doing to kind of cultivate this growth in that community and to accelerate AI. And it's great to see that they're doing that. And I think there'll be a big part of the future. And I think with ARM, they're going to be even more integrated into the smaller things. They're going to be more integrated into the things such as phones, into your cars, into your Echo devices, amongst other things. They'll all be, because going forward, they'll all be their own smart operations within that. There will be their own AI. So with this acquisition of ARM and obviously their computing platform, accelerated computing, they're really going to increase the use of AI, how important it will become in the future. And another area in which it'll become super important is the world of gaming, where Jensen said that gaming is the only entertainment that can be any entertainment. We're going to spend a lot more time in game worlds, not just to game, but just to hang out, to be with people, to interact with people. The gaming market has a great future ahead of it. So much like people on Facebook interact with each other to chat, share photos, share ideas, comment on things, and other such things. Sooner or later, this is going to actually go into a world of its own where you can kind of integrate your real life scenarios into this world scenarios, which can be, obeyed by physics and other things, or not. Really depends on the architecture of the gaming platform or the game itself. And you can go around doing whatever you like, and you can share, interact with other people, live games. And we already see this in like games such as GTA, other such games such as open world games, like even you could play Call of Duty or Gears of War or Cyberpunk. So all these open world games, which are not like, some of them are not really open world, but they more or less quests where you can, it's multiplayer and there's quests and you can go interact and you can hang out and you can earn money if you like there, and amongst other things, and just have a great time there. And that will move forward from this physical world into the gaming world, and that will become more normal in the future. And this is the metaverse, as Nvidia calls it, and or as Jensen calls it. So we'll see what they have to say about that.
If the last 20 years was amazing, the next 20 will see nothing short of science fiction. The metaverse is coming. Metaverse was first coined by Neil Stephenson in his 1992 science fiction novel Snow Crash. Humans as avatars and software agents interact in the 3D space, a virtual reality successor to the internet. With worlds like Minecraft and Fortnite, we're already seeing the beginnings of the metaverse. Though they seem like games today, gamer inhabitants of these early metaverses are building cities, gathering for concerts and events, and connecting with friends. Future worlds will be photorealistic, obey the laws of physics or not. and inhabited by human avatars and AI beings. The metaverse is not only a place to game, we will create the future in these metaverses before actually downloading the blueprints to be fabbed in the physical world. Omniverse is Nvidia's platform for simulation and collaboration. Omniverse is built from the ground up for the future. Cloud native, multi GPU, photorealistic with path tracing and material simulation, and physically based, obeying the laws of physics. Omniverse is designed to connect to many worlds. Worlds like Epic's Unreal, Maya, Blender, Adobe, Autodesk, and others. Omniverse allows designers, artists, creators, and even AIs using different tools in different worlds to connect in a common world, to collaborate, to create a world together. Omniverse is even a world where AI agents are created and learn, a simulator for robots.
So I think we really have to see the implications of such things that Nvidia and Jensen is saying. So going forward, obviously these innovations are powered by Nvidia GPUs and their ability to compute uh, high amounts of data very fast, and like accelerated computing and parallel computing. And so in these, by working in these spaces, they're going to innovate robots, cars, AI in a much faster way than if they would do it were to do it with normal uh, under normal circumstances. By opening up this world to developers, Omniverse is giving everyone the chance to kind of come in and work on this project together, whether they're on like a Unity, AutoCAD, or other such uh, softwares. They can come in and they can work on this project and they can get the work done. But I think the main thing that we have to see from this is the fact that robots can be simulated and understood. Um, it could be magnified 10,000 fold. Like with the video earlier in with the car being simulated, which was I think a few seconds ahead of the car, which was in the real world. Over time, there won't be any need for this real world car to be kind of driving. Like we'll just drive the simulations through every day. Um, we'll just keep it on running, and you might do like 10,000 laps in like 3 hours, with accelerated computing. And then we're going to take that data, which is, it could be on a racetrack, or it could be out in the real world, with the use of maps and other search tools. We can kind of make an accurate representation of the real world in the simulator world. And I think that's what Jensen is saying. Then we simulate robots, cars, other such things, and then we take that data, put it into a real life robot, and then we can it can just get to work. It doesn't have to learn anything new. It already has learned everything it needs in the uh, in that simulator world, which is very close to this real world. And another thing is the fact that they're building robots in the simulator world can give you different, I guess, insights into how to build robots. There can be a lot of limitations in terms of just graphically understanding robots in the real world, where you're pulling things apart, trying to understand different things. How does it operate? Putting it back together. And here you can just kind of more or less uh, streamline it to make that work. I think other than that, there isn't really. Uh, there's so much more I think there is to it, in terms of just the metaverse, like that world that Jensen's talking about, where you can kind of hang out, like much like the movie Ready Player One, where they're in this world outside, they eat and they do their daily things, and then they go into the real world, into the simulator world, um, to kind of earn money, to play games, to kind of develop things and create new ideas. And if necessary, I think Jensen's saying we can bring that back into the real world. If we make a world that's uh, created out of physics and out of real life structures and obeys real life laws, and then we push it back into this. Uh, we take it, I guess, yeah, I guess we're gonna call it a simulation. We're gonna take the simulation and then we take that and put it into the real world, and it should work the same way. That's the big idea, is to take that from the simulated world into the real world, and that gap is more or less, for Jensen, it's the only way it can be closed is with accelerating computing, making more lifelike, ray tracing, and also being able to store huge amounts of data and being able to process huge amounts of data in and out. And that's the big idea behind their metaverse. And also just to create this omniverse is to get a lot of developers into the same field and work on the same idea. You don't have to have this particular kind of software. You can all use different software anywhere in the world and still come in and develop something unique. And the final side is for in terms of Jensen's videos is just to kind of see their uh, world of AI. They've announced a lot of things in this keynote, and we're just going to see what that's about.
GTC, you can see how AI will revolutionize computing everywhere, from scientific computing, cloud, enterprise data centers, edge, to autonomous machines. A few weeks ago, we announced our intention to acquire ARM. ARM is the most popular CPU in the world. Together, we can offer NVIDIA accelerated and AI computing technologies to the ARM ecosystem, reaching computers everywhere. Last year, we announced porting CUDA in our scientific computing stack to ARM. The performance was excellent and the response from the HPC community was fantastic. Today, we're announcing a major initiative to advance the ARM platform. We're making investments across 3 dimensions. First, we're complementing ARM partners with GPU, networking, storage, and securities technologies to create complete accelerated platforms. Second, we're working with ARM partners to create platforms for HPC, cloud, edge, and PC. This requires chips, systems, and system software. And third, we are porting the NVIDIA AI and NVIDIA RTX engines to ARM. Today, these capabilities are available only on x86. With this initiative, ARM platforms will also be leading edge at accelerated and AI computing. Let me summarize some of our announcements at this GTC. First, the age of AI has begun, and NVIDIA is in full throttle to advance this new form of computing. DGX SuperPod is a ready-made AI infrastructure for your AI researchers to become instantly productive. NVIDIA Clara Discovery is a suite of accelerated and AI tools for medical researchers. NVIDIA AI inference compute is growing 10 times every couple of years, and this year surpassed total CPU compute in the cloud. Hundreds of companies are operating services with NVIDIA AI inference, including Microsoft Office, American Express, and Tencent. NVIDIA Jarvis Conversational AI is in open beta. NVIDIA Conversational AI is twice as responsive, 1/3 the cost, and more natural sounding than running on CPUs. NVIDIA's Merlin Recommender is also in open beta, and we demonstrated NVIDIA Maxine, an AI video platform for services like AI video calls. Second, data center is the new unit of computing. We announced the Bluefield 2 DPU, a programmable data center infrastructure on a chip. DOCA with CUDA is the programming architecture. We announced a major partnership with VMware, the industry-leading data center OS platform. We're porting VMware to Bluefield. Someday, 30 to 40 million enterprise servers around the world will be accelerated by DPUs. Bluefield has an exciting roadmap. Over the next couple of years, we will increase throughput nearly 1,000-fold. Third, we're taking AI and data analytics to the world's enterprise. We announced a second partnership with VMware. to enable VMware virtualization for the three computing domains needed for enterprise AI: virtualized, scale out, and container microservices. And we announced that Cloudera is accelerating with Nvidia AI. VMware and Cloudera serve nearly every major enterprise in the world. Fourth, NVIDIA EGX and our network of partners are helping the world's largest industries create and operationalize AI services. It is exciting to see successful EGX trials in manufacturing, logistics, retail, and healthcare. And finally, for autonomous machines, we've created the AI system to write the software and the robotics computer to run it. And with NVIDIA Omniverse, we have a physically based simulation engine to create the worlds to train the robots. The age of AI is in full throttle. Thanks for joining us today at GTC.
So yeah, like at the end there, the about creating software that writes software which creates the robots. That's essentially the big idea behind Nvidia and their world of AI. And also, just to comment on the ARM initiative, we can see that that they're very much working in tandem with ARM, regardless of whether this acquisition goes through or not. They've been working with ARM for a while now, since they made their supercomputers and a bit beyond before that as well. And they're much like the Mellanox acquisition that they recently made. Um, they worked with Mellanox before. They liked Mellanox, the service, the technology, and then they bought the company, and then they let them do their thing again. And they're more or less going to do the same thing with ARM if once the deal goes through. They said that they're going to keep in headquartered in the UK. They're going to run their services as usual. They're going to do their contracting, the architecture, licensing. They can keep the same, and but they'll keep on, um, I guess, adding to this infrastructure and architecture to kind of support uh, uh, Nvidia's IP essentially. So that's a great thing. So even if it doesn't go through, we can see this partnership going forward and to kind of accelerate AI in general. And the big thing about AI is basically from Jensen, again, from this quote, is where he says, I also know that AI is a new way of writing software, and this way of writing software is going to impact every industry because we can now write software that we otherwise could not before. Computing could reach more places that we otherwise could not before. For example, who would have thought that on the roads of the future, a billion computers could be just driving around? Who would have thought that in the future, there will be thousands of computers roaming around warehouses and factories? Those are all new applications that otherwise wouldn't have been possible without AI. Every building will be an AI, everything will be an AI. It's going to generate a lot of data, a lot more computing. The computer industry is going to be gigantic because of AI. It's the catalyst that's been missing. It's the final piece of the puzzle to write the software. If someone can write the software, we can sell a computer. Now we can have computers write software. Those two businesses are long-term secular opportunities. And that kind of sums up Jensen's idea of AI. He believes that AI will literally be everywhere. Everything will be an AI. Everything will be communicating with other things. Everything will be more or less interactive, and kind of everything will be an IoT, essentially, Internet of Things. Everything will be connected to this cloud, connected to this, or be even edge computing where uh, offers seamless computing. So that's a big idea behind AI for Jensen and their team, and that's what they're trying to move forward. Any innovation that they make is an innovation is for forwarding AI. That's what they're trying to do. And if you're an investor who's believes in AI and believes in the world of connected devices, then you should really be looking at Nvidia, as that's all they're focused on. That's all they're trying to do is kind of increase this parallel computing, being able to make simulations more lifelike and being able to run simulations in the simulated world and bring them back into the real world and create a software out of there. And obviously, right now, many of these technologies that NVIDIA is offering, besides the chips and all these physical things that they offer, which is basically where it all starts, um, all this other extra stuff that they offer is kind of free at the moment. It's for developers. It's just to increase innovation. But obviously, as investors, we're looking for profit and we're looking for revenues, and that's something we can think about. When they get to the, I guess, after ARM, essentially. I think because I genuinely think that deal's going to go through. But after ARM, we can expect, it'll bring their developer base to over, I think it's over 10 million or so, or 20 million. It's a lot, but the devices that they'll be in, it's a lot as well. ARM is in 180 billion devices, so that's really going to move forward their ability to kind of implement AI into the world. And with that being said, I'll just recommend that everyone go watch the GTC conference or GTC keynote by Jensen. You can find it on YouTube on their Nvidia YouTube channel. That's where I got this from. So yeah, go ahead and watch that. It's great to kind of understand where Nvidia is moving, and basically everything's about AI for Jensen. And so now we look at ARM and see how it kind of interacts with NVIDIA, and see how it interacts with the goal of AI, because we kind of established that's basically all they're trying to do. They're trying to just implement AI into everything. And so the idea is behind this is for accelerated computing, energy efficiency, and AI will revolutionize all industry. That's a big idea there. And they see that ARM's computing architecture, uh, because it's used by so many different companies. It's used by companies such as Marvel, which Marvell, which has Thunder X2 ARM-based service processor, will be used by, or is being used by, Microsoft Azure. Azuri, Fujitsu launched first ARM-based supercomputer, ranked number one on top 500 supercomputer list. So obviously that's not just a computer for that reason. It's there to kind of, I believe it's for uh edge computing and cloud input output. I think something along those lines. But it's in Japan, and it's very much there for um to be used by the Japan uh, uh developers and computer scientists to kind of work on the problems of Japan. So that's a big idea there. And they're also been ARM's also used by Amazon, which launched its ARM-based Graviton 2 processors for AWS, and also TSMC unveiled 7 nanometer ARM-based chiplets for HPC, or high performance computing applications. And so yeah, it's really important to see that ARM's kind of everywhere. It's the fact that their architecture is so pervasive and so customizable for companies such as Apple. Even they recently announced in their MacBook Air, I believe, that they're going to be using ARM's architecture to build their own chips on top and stop using Intel. So that's a key thing there. So that basically ARM's computing architecture allows for energy efficiency, and that's why it's in places such as smartwatches, tablets, phones, washing machines, laptops, printers, TVs, and you can see all the products that it uses. And it's in 70% of the world's population uses ARM's technology. And Jensen essentially is trying to get the CUDA stack, which is their AI accelerated computing stack, into these places to integrate it with AI. And so if we go over to the next one, and yeah, essentially it's to NVIDIA's AI and GPU IP, and to offer it to ARM's customers. So we can see that there's a ARM CPU ecosystem, and there's the NVIDIA's computing platform, and they're trying to kind of merge it together to make this, I guess, a CPU that does AI. Um, so much like, but the thing about it is the fact that ARM CPU is customizable, whilst Intel's or AMD's is not, I guess, because ARM CPU is more or less an architecture that is used by companies such as AWS and Apple. So essentially, use that architecture and integrate it with the computing platform, have a CPU platform or CPU architecture, and then license that architecture out to customers, such as big companies such as Amazon and others. Um, so that's what they're trying to do. They're kind of if you look at companies such as AMD, they have their own AMD CPUs and their own GPUs, and they're trying to I guess integrate them both into a way for these companies. But these companies already use ARM, so they already have this architecture set and ready to go. Next up is being able to use the Nvidia's platform, and rather than using it separately, Nvidia is just going to merge them both by making it a big one company. So yeah, so we can see that Intel is already doing the similar thing there with their XPU, where XPU platforms inside everything, and this is something that they recently announced. So it's not something that's been on there for a while. This graphics GPU, where it allows for security, database, energy, robotics, automotive, cars, Internet of Things, and for manufacturing. So Intel is just getting into the space where they went from a PC and server to everything else. And AMD is more or less making similar initiatives with, as we can see here, initially leading IP, delivering multi-generational multi-generational leadership, CPU and GPU roadmaps, and advanced technology, data center leadership, PC and gaming solutions. So they're working in a similar space, but not so focused on AI. They're more or less trying to kind of, I guess, increase their reach in the space. They're kind of a new company. Intel has been dominating it on the CPU side of things, and Nvidia has been dominating on the GPU side of things. And now AMD is just coming up to kind of be a massive competitor in that space. And we also seen with the recent changes from by Apple to let go of Intel's CPUs, we can see that Intel's kind of falling back, and now they need to innovate, and that's why they created the XPU. And but they're not really working in the same end goal in mind. We can see it's very clear the way Jensen puts it, the way Nvidia's technology is growing, or and it's the way they're innovating. They're very much focused on AI. That's all they care about, and they just want to make everything AI as possible, and they want to just make software, write software, which makes robots, which makes everything more efficient. And then, like humans can work on things that are more creative and more human-like. So that's the big idea behind them. And obviously, these companies are more or less going to do the same thing, but they will be behind, I would think. I don't think they're not really as innovative as Nvidia is, and their acquisitions are going in a way where they're trying to, I guess, rather than create their own CPU, they're trying to just get ARM. The like I don't know how many exact CPUs AMD has, or how many exact CPUs that Intel has, but I know ARM has the highest of them all, with over 180 billion devices to date, and they all use, and that's only going to grow. I think Nvidia, Jensen said in a video that he believes ARM to be closing to being nearly a trillion devices soon, as everything goes onto the cloud and edge computing becomes more important, and everything is more or less an Internet of Things. And for that to happen, it would need AI. It would need some form of accelerated computing, and that's where Nvidia comes in. So for NVIDIA, these are three pillars of NVIDIA AI: data analytics and training, inference, and application networks. So essentially, to be able to get that training, then make it into a model, put this through, and put it into these application frameworks such as Clara, Drive, Jarvis, Isaac, Merlin, Metropolis for the smart city. So they have all these. They more or less have uh, the foundation set, and now it's just about building on top of them, and that's why they make everything open source, so developers can do their thing. They can use Clara, they can use these frameworks to innovate in the space of science, innovate in the space of robotics. Obviously with Drive, they have that partnership with Mercedes, and we see that with Merlin. They have partnerships with Facebook and others. Essentially it's a recommendation system. um, so it's they very much have these tools set and ready to go, and now it's for the developers to develop on top of them and get the most out of these frameworks that NVIDIA has brought. And the issue with the GPU is, so once they have these models set and ready to go, NVIDIA's GPU is the best GPU to use to kind of use to accelerate this their frameworks or their algorithms or their research, because they can offer accelerated computing. They can have faster rate of input output, have faster higher storage levels. So they're very much trying to innovate in a way that I guess not other companies are looking. I think AMD is the only real competitor right now. No other company I think has a technology um, level to compete with Nvidia. I think in that way you can see that I guess ARM and Nvidia would be kind of anti-competitive. But I think that should be fine. So this is the essential idea for Nvidia there. Another essential idea is for edge offers real-time data processing at source or on-premise data visualization, data analytics, and machine-to-machine communications. So traditionally, enterprises used to have traditional IT applications, and they would go to the cloud to scale and do other things there. But now they're saying with 5G, they can make the cloud the source of this kind of transformation essentially, and put this into their edge AI inference um, graphics card or GPU, and then use 5G to kind of at the enterprise itself. So on premise, so there'll be less latency, there'll be more bandwidth, and it'll be more private. So it'll be interesting to see how that would work. And the frameworks that they have there is for Metropolis, they have Aerial for telco, they have Isaac for manufacturing, they have Clara for healthcare, and they have Cloud or XR for AR and VR applications. And these are all the existing use cases and the new use cases coming into place. And this is why it's big, because of Edge and 5G and AI. I think NVIDIA's will be a big player in this space, as we can already see all the existing use cases such as advertising, network operations, commerce, transportation, healthcare, smart cities, agriculture, airlines, airports, media and entertainment, financial insurance, and now the new cases such as AR games, cloud gaming, VR entertainment, stadiums, sports betting. Not sure why that's important, but sure. Enterprise drones, enterprise manufacturing, autonomous cars, fleet management, and holographic entertainment. And this will all be, as I said, back here on premise with Edge, with 5G, and they'll be using Edge AI inference made by NVIDIA to kind of and to use so to kind of put it use inference it to kind of into the enterprise edge world. So you can probably tell I probably don't really understand as well as I should, but it seems super exciting and but complicated. Um, but we can see that from an investor standpoint, Nvidia's in all three places. So with ARM, they'll be here. With 5G, they'll be there with Mellanox. With here, they have their they have their own graphics card. And then here, well, they'll be serving these customers. So Azure, AWS, and Google Cloud. They all use DGX, which is made by NVIDIA, and this is made by NVIDIA. This is owned by NVIDIA, and this will be owned by NVIDIA. So we can see kind of what they're trying to plan and what we as investors should look for, and whether or not we believe in this future that they're laying out for us. And all this will be part of these use cases as well. So all this will be used in such a way that this will be relevant, and in all these spaces, NVIDIA will be the main contributor. So from there, we can see that NVIDIA is kind of a different company to AMD and Intel. While they're working on, well, Intel, they're trying to just get back to their position They're kind of fallen off in terms of innovation, amongst other things. Um, just in terms of management as well, and we can see that there's been a lot of delay in terms of their processes and their ability to kind of give their customers, such as Apple or Microsoft, their what they want. Microsoft has been trouble for years for not using their by using Intel's CPUs, but they couldn't use any other architecture. But now with ARM and their Surface Pros, that's why their Surface been a big hit because they use ARM's architecture, whilst normal laptops and Windows operating systems they work on Intel, and Intel wasn't just innovating in a way that is, I guess, would accelerate um, Microsoft innovation. AMD's very much growing into this space. I think in the future they'll be one of the major competitors with Nvidia and AMD. So that'll be interesting to see how that develops. But I don't think they're working with the same goal in mind. I think they're just more trying to just to make their place set between the one, two, and three. They're trying to be two or one. Obviously, they all try to be one, but they're in reality they're two. Um, so they're just trying to get on top of everything at the moment and just kind of have the business set, the technology set, and then go move forward from there. Whilst Nvidia has already done that, they've already made their place in terms of graphics, and now they're trying to just innovate, offer as much as possible to developers to be their first choice for developers. That's like customers to them, and from there move forward from there. So with that being said, I just want to say thank you for your time, and if you have any questions, leave in the comments down below. Don't forget to like and subscribe. And yeah, I recommend everyone to go and watch Nvidia's GTC keynote 2020 in October. It's on Nvidia's channel, and I'll see you guys next time.